Hi everyone, today we're going to do a little bit of a review on inverses and then get into composite functions. So jumping right into our first example, we're given this function and note that it's defined on this specific domain. So that means that even though normally lines would have a domain of all real numbers, they're restricting this domain from -5 to +5. So in part A, they're asking us to find f to the -1 of 6 to review from last week. We know because it has that -1 exponent that this 6 is a y value. So that means I'm plugging in 6 for y, or 6 for f of x, and I'm solving for x. So if I subtract 7 from both sides, that means I would have -1 equaling -1/2 times x. And then to get rid of that -1/2, you can do a lot of different things. I tend to multiply both sides by whatever the denominator is. So in this case, I'll multiply both sides by 2, or -2, to get rid of that negative at the same time. You could also divide both sides by -1/2, and that would do the same kind of deal. So then I would have x equaling, gets me a +2. Part B, same kind of idea. If I jump straight to the number, then I see that it's asking the same kind of thing, but obviously more words. So we're determining whether this exists or not, and if it does, we're supposed to find it. So to do this algebraically, I'm actually going to find it first and then determine if it exists or not. So same deal as part A, that this 11 is a y value. So I'm subbing in 11 for y. The same steps as I did in letter A. I'll solve for x, so I'll subtract 7 from both sides. And then I'll multiply both sides by -2, or divide both sides by -1/2. So I'm getting x equals -8. So determining whether that exists or not, I have to think about that domain. Because my domain starts at -5 and -8 is smaller than that, that means even though I got a number, and you can argue that it exists because I got a number, that number itself isn't in my domain. So that's why we'd have to say that this does not exist. And mathematicians, if you haven't noticed by now, are lazy, so I'm just going to write DNE, but you could obviously write it all out. For part C, they're wording it a little bit funky this time. So I see that f to the -1, which just like in part A and part B, tells me that I'm looking at a y value here, even though I know it says x. But I know in that parentheses, it should be a y value, just like it was in part A and part B. And just like how in part A and part B, we found an x value after plugging in that y value, that means this is an x. So this is telling me that x equals 0, and we're trying to find what y is. So I could write this multiple ways, but I'm going to use function notation, that I'm subbing in x equals 0. Minus 1/2 times 0, which means that -1/2 times 0 is still just 0, so my answer would be 7. So another way you could do this example is with a graph instead of doing it algebraically. So to do that, I would graph the original function. You don't even have to worry too much about the domain restrictions when you graph it. Just want to have that graph in there. I'm going to hide this so you can see it a little bit better. All right, so when I'm looking for f to the -1 of 6, we already explained that that's a y value. 6 is a y value. So I would go to a y value of 6, over to my graph, and down to the x value of 2. That's it. So just like we were doing last week, you could still use the graph for all of these. Same thing with f to the -1 of 11. If I go up to 11, over to my graph and down, I'll easily see that I'm over here at -8. I know from the problem that the domain stops or really starts at -5, which is over here. So I'm outside of my domain, so I could clearly see that it does not exist. So these could have all been used or found by using a graph. If you do choose to do that, if this was an IAB exam question and you chose to use the graph, you would have to provide a sketch of the graph for your work. So just be aware of that. So in part D of this same question, we're being asked to find the range. So if I were to do this algebraically, I have my endpoints of my domain. I need to figure out what the associated endpoints are for my range. So that means I'm going to have to do two things. First, I'm going to have to find f of -5, so subbing in x equals 5. And then I'm also going to have to find f of +5. All right, so working each of those out either in your head or in your calculator or with a calculator. For -5, I end up getting a +9.5 or 9.5. For +5, I end up getting a +4.5 or 4.5. So now, even though -5 was the low end of my domain or my smallest value of my domain, it actually gave me comparatively a rather large y value. And when I subbed in the upper end of my domain, I got a smaller y value. So just because I went kind of in order with my domain, that doesn't mean my range would be 9.5 to 4.5. Remember, both domain and range, when you list them or when you state them, they have to go from smallest to greatest. So because of that, and I'm going to skip all the way over to the left-hand side here, my range would go in interval notation from 4.5 to 9.5. Again, using brackets because they are included. I got points for both of those, so they're included. You can also use inequalities. So 4.5 is less than or equal to y, which is less than or equal to 9.5. Either way, like I've already said before, I'm preferential, or my personal preference is interval notation, so I'm just going to leave it like that. For part E, they're asking us to state the domain and range of the inverse. So now remembering from last week, we said in general, inverses, you're switching x's and y's all the time. In any type of inverse situation, that's what you end up doing. So if I have the domain of my original function and I now have my range of my original function, they're just going to flip-flop for my inverse. So my domain for my inverse, it's going to be what my range was for the original function. So 4.5 to 9.5. And my range of my inverse is going to be what it was, what the domain was for my original function. I'm going to switch it into interval notation. Again, just personal preference, but you could just copy it straight down. So you're just switching the x's and the y's, right? Switching the domain and the range. So for part F, we're being asked to find the inverse itself, leaving our answer in simplest terms. So we had mentioned last week that to find the inverse algebraically, you take x and y and you switch them, and then you just resolve for y. So that's what we're going to do. So I have my original function up here at the top, remembering that f of x is the same thing as y. So I'm going to interchange x and y. So I have x equals 7 minus 1/2 y. And then go through the steps to solve for y or to re-isolate y. So y right now is being multiplied by that -1/2, which means I'm first going to get rid of that 7. So just like how we were talking about in the previous slide, I can either divide both sides by that -1/2, or like I had said previously, that I just like to multiply if I can. Multiplication is easier to do in my head. So if I can do it, I'd rather do that. So I'm going to multiply both sides by -2. Note my use of parentheses on the left-hand side, though. That whole left-hand side is going to have to get multiplied by the -2, either in this step or in the next step. So because of that simplest terms, I have to leave my answer in simplest terms, which which means I would have to distribute that -2. So y equals -2x plus 14 is my inverse. All right, our last example is about composite functions or compositions of functions. So we're going to see two different styles or two different examples of composite functions. So letter A, you'll notice two distinct things. One, they use an open circle, which just means composition, that we could rewrite it as you see kind of in letter B as f of g of 8. The second thing is that you have the 8 there versus B, you see it's just an x. So when you have a number in the composition that you're being asked to find, your answer should also be a number. Versus you have an x in the question, then your answer should also have an x in it. So this part A, we're finding an actual number. Part B, we're finding a new composite function. When you do part A, there's lots of different ways that you can do it. What I like to do is work my way inside out. So I'm going to take that that g of 8, and I'm going to evaluate that first. Right? Just like how I did in the last example when I was finding the domain and the range, just the range. I'm just subbing in. I'm subbing 8 in for x of g. So I'll be doing 8 minus 6 and get 2. Then I'm going to take that f and use that. So in part 2, I'll be doing f of the value that I just got. So f is this x squared minus 2x plus 3. So I'll be doing 2 squared minus 2 times 2 plus 3. Which means 2 squared is 4 minus 4. So that's 0 plus 3. So my answer is 3. Okay, so again, because I had the 8 there versus a variable, I get an actual number as my answer. All right, so part B, f of g of x. Again, because I have the x there, I should be getting a function as my answer. So what this tells me is that I'm taking g of x and I'm subbing it into f. So what might help, because it might look a little more familiar like we did over here with the numbers, is I know what g of x stands for. I know what g of x equals. I know g of x equals x minus 6. So I'm going to sub x minus 6 in for g of x. That way it might be a little more clear to me that this is what I'm subbing in to f. I'm taking x minus 6 and I'm replacing both x's in f with that x minus 6. So I'll have, again, no parentheses, x minus 6 squared minus 2 times x minus 6 plus 3. Okay. So one key thing to remember that a lot of people often it floats out of their brain is you cannot just distribute the square here. If you feel like you're going to, what I want your next step to be is to expand that out. If I have x minus 6 squared, that means I have x minus 6 times itself. And that'll help you to remember that you need to, whatever you want to call it, distribute, FOIL. You can use the box method if you have space, but you need to expand that out fully. If you just distribute the square, you're going to miss your middle terms. So make sure if you think you're going to forget, just write that out real quick and then go through all of the distributions. So I've fully distributed the x minus 6's and I distributed the -2. And now I'm just going to start combining like terms. X squared doesn't combine with anything. I have -6x, another -6x, so together that's -12, and a -2, so -14x. And then I also have this plus 36 plus 15, so that's plus 51 as my final answer.